Okay, so today or this lesson is box plots, and the good news is you guys are already familiar with a lot of what it takes to build a box plot. The only thing that will be new to us is actually building the box plot. So up here we have a little fill in the blank. This fill in the blank is a box plot is a visual representation of the 5-number summary. And the 5-number summary, you guys already know how to find and you know what it is. So it is the minimum value in your data set, your first quartile, your median, your third quartile, and your max. So the 5-number summary is something very important in statistics, and it's very common in statistics and gives you a really good picture of the data. So let me tell you how you use this to build a box plot. So let's say this is your minimum value. So we're going to say this is our min. Then we're going to draw a straight line coming out of the middle of that. So this is your min. Then you have like a rectangle, which is the box. Sometimes the box is really long, sometimes it's very short. Then you have another straight line coming out, and this would be your max. So on the lower end is the minimum value, and on the upper end is the maximum value. This part of your box, or the beginning part of your box, is quartile 1. The median will cut your box in two. Actually, I want it to be even further over than that. I want it to be closer to the right-hand side, because I want it to be clear that I am not cutting this rectangle in half. Your median isn't always in the center of the rectangle. So your median doesn't cut the box in half, it cuts the box in two. So this is our median. So what do you guys think this one is? Quartile 3. So one important thing to note about box plots is that this tells you how much of your data is in each section of the box plot. So what this means is that 25% of your data is between the minimum and quartile 1. And 25% of your data is between quartile 1 and the median, and so on. So this chunks your data out into 25%. And you'll see why on some of your practice problems it does this. But for now, it's just important to note that it's separating your data into quarters. The really cool thing, or the thing that I like about a box plot, in addition to that they're easy to make if you get your 5-number summary, is that if you have an outlier, it is outside of these are called whiskers. It's outside of the whiskers, and it's an actual outlier. So what I mean by that is it is determined to be an outlier by 1.5 times IQR. If you see a point outside of the whiskers on any box plot, it is a legitimate outlier. So I'm going to put a couple on this end too. And I'm going to write outliers determined by IQR, or 1.5 times IQR. So any points outside of the whisker on a box plot are legitimate outliers. So this is just a made up one with no data. It's just the basics. It goes from your min to your max. It includes your quartiles, and it splits your data up into quarters. So far, so good? Okay, let's learn how to make one. Now, typically you would order these least to greatest on your own, but to help us save a little bit of time, I am going to help you with that. So I'm going to just list it out left to right. You might want to write a little bit slow, and by slow I mean small, because there's quite a few numbers. So the first one is 16. These are, I guess I should tell you what the data is. These are Barry Bonds' home run numbers in his 21 seasons that he's played. So we've seen this data before. These are the total amount of home runs he hit for each of his 21 seasons. So the lowest amount that he hit was 16. Then 19, 24, 25, 25, 26, 28, 33, 33, 34, 34, 37, 37, 40, 42, 45, 45, 46, 46, 49, 73. And then I'm going to double check that that's 21. Okay, we got them all. Okay, so first step, we need to order least to greatest, and now we know what our minimum is. That's 16. We know what our max is. That's 73. So now the next easiest thing for me personally to find is the median. So the position of the median is the number of observations, 21 plus 1, divide by 2. What does that give us? 11. So that means the median is the 11th observation. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11. So it's the second 34. And then to find my quartiles, so sorry, I'll write my median in that position. To find the quartiles, I cover up all the data to the right, so the median and all the data to the right, and I find the middle. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 observations, which means that your quartile will split that in half. So 10 observations divided by 2 is 5. So 1, 2, 3, 4, 5. Your quartile is in between there, because then the next one has 1, 2, 3, 4, 5. Now, if you're doing the formula, the position of your quartiles is 10 observations plus 1 divided by 2. That gives you 5.5, which tells you it's between the 5th and 6th observation. I knew that there were 10 observations to the left of the mean because I counted them. So I do 10 plus 1, divide by 2. So now I'm going to mark those. 1, 2, 3, 4, 5. Okay, so for our quartile 3, hopefully that one's easy for you. What is quartile 3? 45. Quartile 1, though, is between 25 and 26. So if you don't feel comfortable doing that in your head, you do 25 plus 26 divided by 2. That gives you the number in between 25 and 26. So what does that give you? 25.5. This also works for quartile 3. If you did 45 plus 45 divided by 2, you're going to get 45. You're hanging in? Okay. So the one last thing that we need to know is whether or not there are outliers in this data set. And when we say outliers, we mean legitimate outliers. So we have to do 1.5 times IQR. So step number 1, find IQR. So you guys find it and I'll pull names. You guys find IQR. Got about 20. You definitely gonna need your calculator. 5, 4, 3, 2. Okay, goes to Maddie. 19.5. I agree. So IQR is quartile 3 subtract quartile 1. Okay, so now I'm going to find my lower bound. So I take quartile 1, this is 25.5, and I subtract 1.5 times IQR, which is 19.5. How do I know this? Because we had a whole worksheet on this. So you guys have about 20 seconds to plug that in, and I'll pull somebody's name. We got about 5, 3. Okay, this one goes to Ella. -375. So there are no outliers on the lower end because Barry Bonds can't hit negative numbers of home runs. Okay, you guys find the upper bound without me giving you the formula, and I'll pull a stick for that one. $20. $10. 5, 3, 2. Okay, she's in the next period. Abby's not here. Victoria, what did you get? Perfect, 74.25. So, surprisingly enough, this one season where he hit 73 home runs was not an outlier. Does that surprise you guys? Surprises me. So, last part, now that we know we have no outliers, is we build our box plot. So we make an x-axis and we label it number of home runs. Is that one word or two? One. And like we normally do, we're going to use our minimum and our maximum to decide where we should start. So our min is 16. So I think we could start at 10 or 15. You could go as low as 0. What do you guys want to do? Anyone? 10. Great. And we need to go all the way up to 73. So I think I would go to 75. And what should we scale by? 5s. So I'm going to go from 10 to 75. Each tick is 5. And you don't have to put all the little ticks in between, just go by 5s. Is 20 seconds enough? About 5. Okay, so now we go in number or in order of our 5-number summary. So up here, these are the points that we plot. So the first point that we put down is on 16. So I'm going to eyeball where 16 would be, leave about a 1/2 inch, and make my first dot. You could go even higher than that if you want to. Then my next dot is at 25.5, so I'm just going to eyeball that. And you want them to line up horizontally as best you can. Next up is our median. Quartile 3. And our maximum. So as best I can, I've tried to get them in a straight line. This guy, he's not living his best life. He's rebelling. Have a rebellion going on there. Okay, once you have those down, go to your minimum and connect it to quartile 1 with a horizontal line. And then go to your quartile 3 and connect it to your maximum with a horizontal line. You may need to adjust your dots. Oh boy, Mayday. Maybe we should have rulers for this. Oh, so much better, family. Look how much better I did that time. So then all that's left is the middle 50% of the data. So the middle 50% is actually the box in the box plot. So I draw a line through quartile 1, a line through quartile 3, connect the bottom and the top, and then I draw one last line through the median. So that's our box plot. So this is the middle 50% of the data. This is the bottom 25% of the data. This is the top 25% of the data. The data is the most spread out on the right side, which makes sense because he had home runs of 73, but then the one before that was 49. So that is a very large spread between 49 and 73. So it would make sense to me that the longest part of this box plot is that stretch from 49 to 73. Does that make a little bit of sense? You're sure? Okay, we can actually tell the shape of a distribution based off of the box plot. And here's how you do it. You go to the median. So we line up with the median. I'm just drawing like a dotted line. And you calculate the length of each side of the box plot. So the left side would be the median, 34, subtract the minimum of 16. So what does that give us? 18? So this distance, where my fingers are, the left-hand side of this graph, is 18 home runs. Is that making a little bit of sense? So I think I'm going to highlight that. I'm going to do some highlightage. I'm going to choose a wonderful color, family. Ugh, teacher, failed. So that distance is 18 home runs. You typically would not color in your box plot like that, but you know, YOLO. Or whatever the kids say nowadays. Do you guys have any expression that matches YOLO? Tiara, you're in the know? Fine. Okay, now we're going to calculate the length or the distance of the right side. So this time you take your maximum, 73, and you subtract the median of 34. That gives you 39. Holy shamoly. So that is this distance. If one side is longer than the other, your distribution is skewed. If one side is longer than the other, you have a skewed distribution, and it's skewed to the side that is bigger. So what is the shape of Barry Bonds data? Right skewed. And you can do this for any box plot. So this was the median, subtract the min. This was the max, subtract the median. That works every single time. Box plots are the best. Yay, box plots. I think they should be homecoming queen and king. Who are the boy nominations? What? Oh, people already won? When did we vote? Okay, who's the girls? You mean my box plots they're not even gonna get a sash? Little boutonniere? Okay. Okay, you ready to go to the next side? So this is basically it. That's how you make a box plot. So let's make some more. On this side. This time they want us to make a side-by-side box plot, one on top of the other, and down here they tell you which one to make where. So the information that they give you is the 5-number summary of the temperatures in Magna and St. George in March of 2015. So they give us all the information that we want. They give us the minimum, the quartile, medium, quartile, maximum. What is the only thing we don't know that's important to a box plot? Outliers. So you need to decide for each city if there are outliers. So for Magna, you need to find the IQR, then the lower bound and the upper bound. Then for St. George, you do the same thing. You find your IQR, and then use that to find your lower bound and your upper bound. So I'm going to bring around your next worksheet while you guys do that. So pencils should be moving. Brains should be working. If you don't know how to do it, then go back to this front page and do what we did. Okay, we'll go about another minute. I think I'll pick sticks to see if there are outliers. So I won't ask you the number, I'll just say, are there outliers? About 45. $30. $10. Okay, Jacob learns at home. Caleb, are there any outliers in the Magna set?
Yeah.
How many? One. Emmy learns at home. Ernesto, are there any outliers in the St. George set?
Yeah.
How many? 2. I only got 1. Only got 1. So I have an outlier in Magna at a temperature of 45 and an outlier in St. George at a temperature of 85. Is that what you guys got? Yeah? Okay. So now we plot them. I'm going to start with St. George just because he's closer to the line. $88 is the outlier. No, you don't count the 85. It has to be bigger than the upper bound. So it can't be 85, it has to be bigger than 85. Good catch, thank you. Okay, so the minimum in St. George is 62. Quartile 1 is 70. Then the median is 74. Quartile 3 is 76. Oh boy. Is that true? And now your maximum, instead of being 88, what should we use instead? 85. Then I'm going to connect those two. I do my box after I connect the lower and upper quartile. And then the last thing that I'm going to put on is that outlier at 88. So that is St. George with an outlier of 88. Do you guys want to try Magna without me? Thank you. So take a minute, try Magna. I'll plot mine and then I'll walk around the room to see how far you got. Oh no, this one's much higher. At least put the points down. Okay, about 30. $10. Okay, here's mine. Do ours look similar? A little bit. Okay, what's the last thing you're supposed to do on this page? Compare the distribution. So I can hear some of you guys saying it quietly. We're going to come back to this if we have time, but if we don't, this will be part of your can you do. Now, the only thing that you need now to compare these distributions is shape. And if I were determining shape, at least for this one, I wouldn't really want to eyeball it because I'm not quite sure. So what I would do is come up here and I would find the length of the left-hand side for Magna and the length of the right-hand side. And then I would do the same for St. George. Do you want to try that really quick? Was that a yes? Was that a yes? When you do your maximum, like for, or actually for Magna, when you go to do your minimum, do the minimum on the graph. So don't use 45, use 51. Does that make sense? Okay, go. This should only take a little bit. That doesn't seem right. Okay, for Magna, I got 15 and 13. And for St. George, I got 12 and 11. I think that those are both roughly symmetric, personally. I think if you look at the range of temperatures, so for here, the range, if you include the lower outlier, is 34. With a range of 34, I feel like being off by 2 degrees isn't that much. Here, the range is 26. And once again, I think that these are close enough considering the range. So I think I would say that those were both roughly symmetric. You're okay there? Okay. So let's move on to the page that I brought you while you were working. He has a histogram on the front side. The sizes in square feet of the 2020 rooms in a student residence hall at a certain university are summarized in the following histogram. Based on the histogram, write a few sentences describing the distribution of room size. So, okay. Well, there's definitely a bimodal situation going on here. Would you agree? We have rooms that are smaller, between 100 and 200. We have a bunch of rooms, and then a bunch of rooms that are bigger, which would make sense. I wonder if these are like the freshmen, sophomores who 4 or 6 people have to live in the room, and these are the upperclassmen where 1 or 2 people have to live in the room. So even though it's smaller, you get more space. You get what I'm saying? So because we have to describe the distribution, I want you guys to try to identify where the median would be. Is that all I want you to do? Yes. You guys find the median. Take like a minute and find the median bin or the median bar. Okay, about 20. 10. So I have that he is like right on the 250. There are 20 rooms that they got the size of. So that means that the median is in between the 10th and 11th observation. So it's like right on that 250 line. Does that make a little bit of sense what's happening there? But because this is a histogram and we get no specific information, we don't know for sure whether the median is in this left-hand bin or whether it's in the right-hand bin. We just know that it's in between an observation in this bin and an observation in this bin. So in this case, we would say that the median is 200 to 300 because we don't know where that median is. We only know what it's between. So we don't know what bin it is in. We just know it's between the 10th and 11th observation. So we have to include both bins. So the lower end is 200 and the upper end is 300. Okay, let's fill out the information for this distribution. The distribution of the sample room sizes is bimodal. Bimodal and roughly symmetric. With most room sizes falling into 2 clusters. Your first cluster is from 100 to 200 feet, square feet. And where's the second cluster? 250 to 350. Okay, in parentheses, an alternative option would be for you to say, this distribution is bimodal and roughly symmetric with a peak at 150 to 200. And another peak at, where's the other one? So you don't have to do both. You can do one or the other, whichever makes most sense to you. But you would, for full credit, need to either say there are two clusters or there are two peaks and identify where they're at. The center of the distribution is between 200 and 300 square feet. The room sizes vary. The room sizes vary from 100 to, what's your upper end? 350. What that is range. What that is the lowest value to the highest value. Now, an alternative option would be to actually give the range. So what is the formula for range? Maximum subtract the minimum. Well, that's weird when you have a histogram because everything is intervals. So in order to find out what interval this would be, you take the maximum value, which is 350, subtract the minimum value of 100. What does that give us? 250. But then we have to do it for the other side of the bin. So we just did this, the outsides. Now we need to do 300 subtract 150. So we did it for the max and the min for one side of the bin. Now we have to do the max and the min for the other side of the bin. So what does that one give us? 150. So what we just calculated is the actual range. The actual range in terms of maximum subtract minimum. So that range is anywhere from 150 to 250. Personally, I don't think I would ever use the range, and I believe you're fine if you don't. I think that I would have just given the lowest value to the highest value. It's up to you what you use. Are you okay there? Is that a yes? Okay, does there appear to be any outliers just by eyeballing it? No, there does not appear to be any outliers. So now they give us the summary statistics, which is basically the 5-number summary for this data set. It's not giving us the values of all 20 rooms. It is giving us the summary statistics for the 20 rooms. And it wants us to determine if there are outliers and then make the box plot. So to help us along with that, I will give you the lower bound and the upper bound just to make things a little bit quicker. So your IQR is 292 minus 174 which is 118. Your interquartile range is 118 square feet. Your lower bound is 174 minus 1.5 times IQR. So your lower bound is -3 square feet. Your upper bound is 292 plus 1.5 times IQR. That is 469. So we go up to this table. There's obviously no outlier on the lower bound because you can't have negative space. But on the upper end, you go and you look at what your maximum value is. So did we have any numbers above 469? No. So there are no outliers. Okay, so next up, we use this knowledge to make our box plot. So our minimum is 134. They're going by 20, so be careful about that. Their scale at the bottom is going in 20s, so you have to split it into 10s. So minimum is 134. Quartile 1 is 174. These are a little bit tough because of their scale, so you're just going to do the best that you can. Median is 253. Quartile 3 is 292. Max is 315. Mia, did I bring the can you do's? Okay, so here's my box plot. And one of the first things that I noticed when I finished is the shape of this box plot. What is the shape of this box plot? Roughly symmetric, right skewed, left skewed. This thing is left skewed. This thing is definitely left skewed. The left-hand side equals 119.5 and the right-hand side equals 61.5. So I thought that it was very interesting that as a histogram, it looks roughly symmetric, but then once we change it to a box plot, it's totally left skewed. The reason why that is because remember how depending on your bin size, you can make histograms look really different? Do you guys remember that? Okay, there's one last question on this side, and it is, what characteristic of the shape of the distribution of room size is apparent from the histogram, but not from the box plot? The box plot does not show that the distribution is, what do you think? Bimodal. So I was really bothered by this problem yesterday, so I spent about 30 minutes playing around with the bin sizes and the data to see if I could make that histogram at the top look left skewed. And you can, depending on what values are in those bins, you can make it look left skewed. But I think what they're getting at is they want you to notice you can't see things like clusters or gaps or bimodality or multi-molds in a box plot. You can't see those things. You can see if it's left skewed or right skewed, but you can't see clusters, gaps, peaks, things like that. Are you guys okay there? Yes? So then to finish this up, we just have comparing distributions. And that'll go pretty quick because you already know how to do this. We've already talked about this. We're just doing it in terms of box plots. So you'll watch a video for that and then complete your can you do. We're good there? Okay, I will bring you your can you do.